Good day, Doctor. My name is Moni Hong. I'm from Group 12, and our group is managed to monitor the quality of pure Lajakkuruih. For our group, will consist of 4 members. Our team leader is Chong Xin Shen, and Muhammad Rifki Siding, and also Lin Jing. Then, for today, we will discuss about the summary of data, goodness of fit test, ANOVA analysis, and also linear regressions analysis. Here is the data given by manufacturer. There are 200 sample data of weights, relative density, and tensile strength in different shifts, which is morning, evening, and night. I will summarize the data using the numerical method first. Then the diagram shows that I use the pivot table in Excel to summarize the data in terms of weight, relative density, and also tensile strength. Each term of the parameter it consists of count, sum, average, variance, standard deviation, means, and mass in the shown in the diagram. For the tabular method in terms of weight, I group the weight in the interval of tens, and we can see the most count is 61, which between 340 until 350. In the table beside is the summary data of weight of standard templates, and I using the graphical method to plot the graph of weight of standard templates as shown in the diagram. For the tabular method and graphical method in terms of relative density, I group the relative density in the interval of 2. Then we can see the most count of relative density is 43, is between the 87 and 88. The table beside it is the summarized data for the relative density, and the graph below is the summary of data using the graphical method. In tabular method of tensile strength of standard templates, I group tensile strength in interval of 0 by 2. Then we can see the most count of tensile strength is 77, which between 7.1 until 7.3. And the table beside it is a summarized data of tensile strength. And I plot the graph using a graphical method as shown in the diagram. Then that's all from me, and I will pass for my next member. Thank you.
Hello everyone, I'm Lin Jing, and now we'll continue with the qualification test based on the weight. For the requirement, we want to know whether the weight of the standard tablet is normally distributed with 350 milligrams with a standard deviation of 40 milligrams. The method we use to solve this problem is a goodness of fit test, which is a chi-square test. This is our hypothesis statement, where the null hypothesis statement states that the weight of the standard tablets follow a normal distribution with a mean of 350 milligrams and a standard deviation of 40 milligrams. And the alternative hypothesis states that the weight of the standard tablets do not follow these distributions. Constructed a frequency table to categorize all the weight from more than 320 mg to more than or equal to 380 mg, and each category will have a range of 10 mg. Table A shows how we construct the chi-square test, where we calculate the probability for the tablet to have such a weight by using the z-test, and then we get the expected value, which is the expected count of the tablet that will have that weight inside that category. You can see that we combine the first two rows and the last two rows because the first and the last expected value is more than 5. That's why we combine it to make it more than or equal to 5. After that, we calculate the chi-square test value by using the observation value and the expected value, and we get the total chi-square test value with 9.4197. From table A again, we get the k is equal to 6 after the combination of rows. And in our case, we construct this chi-square test as a significant level of 5%, and we get the degree of freedom is 5. The chi-square p-value is 11.07. Since the chi-square test value is 9.4197, which is smaller than 11.07, we do not reject H0. There's not enough evidence to reject that the weight of the standard tablets follow a normal distribution with a means of 350 milligrams and a standard deviation of 40 milligrams at 5% significant levels. Thus, we can conclude that the standard tablets are normally distributed with a means of 350 milligrams and a standard deviation of 40 milligrams. That will be all for me, and I will pass to my next member. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rifki Siddiq, and I will present part 3 about comment on whether there is any significant difference between tablet weights from the different shifts. So, from the data that we got, we extract the weight of the tablets and divide it into 3 sections by each shift: morning shift, evening shift, and night shift. On the left, we can see the data that have we extract from the main data. This is the data we got, and after that, we use this data to analyze with one-way ANOVA method. So, the first part is, what is the purpose of this method? Comment on whether there is any significant difference between tablet wakes from the different shift. And we point the main data that we got from the left data. The total sample is 200, the total section is 3, and the confidence interval is 95%. So we can put our hypothesis in the initial hypothesis. There is no significant difference, atau S0. There is no significant difference between tablet wakes from different shift. And the second hypothesis, there is significant difference between tablet wake from different shift. So using ANOVA, we can get in groups morning, we get 65. This is the data from groups morning. This is the evening, and the data from groups night. And this is the ANOVA, that we can see the sum of square, degree of freedom, mean square, and the F-test data, p-value, and F-criterion data. Decision rule: reject H0 if F-test bigger than F-criterion, that 3.04. And we got this F is 0.5, so F-test is smaller than F-criterion. So don't reject H0. Conclusion: at alpha equals 0.05, there is no significant difference between tablet wake from different shift.
And now we are going to present about the part 4 relation between the tablet tensile strength and its relative density. So we are going to use the regression test to test the relationship between these two elements. And what is the regression test? The regression test is used to test the relationship between the response, which is also the dependent variables, and the predictor, which is the independent variables. In this case, our response, which is the Y, is the tensile strength, and the predictor X is the relative density. So this is the result from the Excel data analysis, and you can see we can get two data, which is first is the alpha, and we also get the gradient, which is the relative density, is the beta, and based on these two data, we can use to form a simple linear regression model. Now we come up a question: is this SLR model ready to carry out the prediction of the tensile strength? In order to test it is ready or not, two tests are carried out. Since the SLR model is the linear equations, so now we'll carry out the linearity test. And from the data, we can get the p-value of the beta, and now we are doing a hypothesis test, and we set the rejection rule is that we will reject the null hypothesis when the p-value of the beta is smaller than the significance level of 0.01, and this 0.01 is actually set by ourselves. And now you can see that p-value of the beta is much smaller than the 0.01, so we are reject the H0. What does this mean? This means that we can conclude that there are a strong linear relationship between the tensile strength of the tablet with its relative density at the 0.01 significance level. Since we are agree with the linearity of these two elements, now we will come up with this relative density line fit plot from the Excel's analysis. And actually, the assumption which is when the relative density is 0, the tensile strength should be 0. This assumption is further come to the intercept C should be 0. But when we extend the line of this relative line fit plot, we can see that the intercept is not 0. So actually, they have the standard error. Since they still have the standard error in estimating the coefficients of the SRM model, now we further test the validity of its coefficient by using its confidence interval. We have set our confidence interval into 99%, and this data also can get from the Excel data analysis. And from here, we can conclude that the both estimate value of the alpha and beta are still within the range of the 99% of the confidence interval. Thus, the SRL equations are still valid to be used to estimate the tensile strength of the tablet. Since we have confirmed the validity of this SRM model, now we can use this SRM model to estimate the tensile strength of the table by using its relative density value. And after we get the result, and now we are further asked, is this whole model adequate for using to estimate the tensile strength? This model is actually adequate because it is follow the assumption that the residual you see is now scattered randomly around the zero with the constant variation. And actually, in the data analysis from Excel, it's given us the regression statistic, and from the regression statistic, we are given a R-square value. And from this R-square value, we can conclude that there are 73.74% of the original uncertainty in the value Y, which is the tensile strength, can be explained by this SLR model. And since the 73% is quite high, we can conclude that the SLR model is adequate to test the tensile strength using its relative density. So that's all from our group. Thank you.